All right, we're going to start talking today about, I think, what is a very interesting area, chemical accidents, and I think it's obvious why we're going to talk about that. But before we get to the current problem in terms of chemical accidents, it's interesting to take a look at a little bit of history. So we're going to go back to Halifax, 1917, and a tragic day in Canadian history. I suppose many of you do know this story of the Mont Blanc, a ship that was carrying a very large amount of picric acid, which is a high explosive, and TNT, and gun cotton, fuel oil. Now this was 1917, of course, it was in the midst of the First World War. So these were all weapons and explosives that were destined for Europe. And they had been loaded onto this ship in Halifax, but in the Halifax harbor, what happened was that the ship met up with another ship that you see at the bottom, which was a Belgian ship, and they collided, and there was a tremendous explosion, and the extent of that was absolutely devastating. And this is just about the only picture that there is of the actual explosion. Someone just by chance happened to get it. But the after effects were just terrible. As you can see, the windows reported broken halfway across Nova Scotia. So this was absolutely astonishing explosion. And Halifax really was virtually destroyed by this explosion. Look at the after effects. I mean, basically everything was just devastated. And you know that Halifax was not a village at that time. I mean, obviously it was not as large as it is now, but it was a city of significant size. Here's another very interesting picture, because in the background is the ship with which the ship that carried the explosive collided. And you see, it's just absolutely utter devastation. And if you go to Halifax, there's a memorial there that you can visit. And that's what it is. It's got all kinds of bells on it, and I guess they ring the bells on the anniversary of the explosion. So this is, you know, an epic moment in Canadian history, and you know, many people in Canada don't know this story of how, you know, Halifax was virtually wrecked because of this explosion. Now let's go to Texas City. In Texas in 1947. Again, it was in the harbor, and the ship called the SS Grand Camp was also loaded with explosive material. It carried 2 million kilos of ammonium nitrate, which is an explosive, and fuel oil as well. Nobody knows exactly what triggered the explosion, but it was triggered all right and exploded. Ammonium nitrate, very dangerous substance, because when it is heated, it very quickly decomposes and it forms water and nitrous oxide. Now you would think, so what? It forms water and nitrous oxide. Nitrous oxide is just laughing gas. Well, this is nothing to laugh about, because the nitrous oxide further decomposes to nitrogen and oxygen. And again, you think, so what? I mean, that's just air, right? Air is 80% nitrogen, 20% oxygen. So what's the big deal here? Well, the big deal is that any explosion is caused by the sudden expansion of gases Doesn't matter what the gas is. Gases expand with heat. So the massive volume of water and nitrous oxide and nitrogen oxygen that was produced just caused a shock wave to spread all around. And once again, the results were just totally devastating. This is about 5 miles away from the explosion. And you can see the house is destroyed. This parking lot is 10 miles away. This was some explosion, right? And this was 1947, so this was a peacetime explosion. Now the ammonium nitrate, we'll get back to this. While ammonium nitrate is indeed a high explosive, it is also an outstanding fertilizer. And that's why the ship was carrying it. The same substance, ammonium nitrate, caused the Oklahoma City explosion in 1995. And this already is in your time frame, so you will remember this. This was a federal building, and this was not an accident. This was homegrown terrorist, right? McVeigh, and parked a truck full of ammonium nitrate next to the building and detonated that. And see the results. There was a kindergarten in the building. So altogether, I think there were 136 people who died, including the children in the kindergarten. He was caught. McVeigh was caught. He was tried and convicted. Never showed any remorse. He just wanted to destroy society, essentially. And he was tried and convicted and executed. Never ever shown any regret. Yeah, right to the last minute. And he was executed by lethal injection. And the way that is done is with 3 different chemicals introduced sequentially. So they put first an IV line, in this case they put it in his leg. The first chemical that is administered is sodium thiopental, which is a barbiturate, and that just sedates, basically causes a light sleep. Then they put in some pancurium bromide, which is a derivative of curare. You've heard of curare. Curare is a poison that's extracted from a vine that grows on a tree. And it was hugely successful when it was first introduced into medicine, because it prevents muscles from contracting. And surgeons don't like it when they slice into you and your muscles start contracting, so that's why those muscle relaxants are used. Of course, here it is used in a high enough dose that it paralyzes the lungs. And then potassium chloride is injected, and that stops the heart. So that's the way that lethal executions are carried out. And today in the U.S., I think every state where executions are carried out is now done this way. I think the electric chair has been dispensed with because it was thought to be too inhumane. And this is a more humane way of killing people. Then there was, in 2020, the explosion in Beirut. Once again, this was ammonium nitrate, which was being stored in a large storage tank right on the coast as fertilizer. It's the most common fertilizer used in the world. And again, it's unknown, what happened here. But really, all it takes is a small fire to ignite a large amount of ammonium nitrate. The result of this explosion in Lebanon, take a look at that. I mean, every house in the vicinity totally destroyed. And this was like that for about a mile inland. So ammonium nitrate is very potent. But it's also interesting to talk about ammonium nitrate because, you know, it is the classic double-edged sword. Ammonium nitrate is a fertilizer, and it is credited with really the Green Revolution, which allowed millions of people to be fed that otherwise were not fed, you know, dating back to the 1930s and the 1940s. Ammonium nitrate provides the nitrogen that crops need in order to grow. And it was a substance that could not be synthesized until the early part of the 20th century, and that credit goes to Fritz Haber, Jewish-German scientist. He was a big German. He supported in First World War, total support of the German regime. And he developed a process for making ammonia. And this is one of the most important chemical processes ever developed. I mean, it looks very simple. You know, nitrogen and hydrogen to form ammonia. But it took a lot of research for that to happen because it needs a high temperature, it needs a high pressure, and it needs a catalyst. And Haber was able to do that. What is the importance of this? The importance is that ammonia can react with nitric acid and you form ammonium nitrate. And this really was the key to providing food for a large part of the world, particularly in Asia, India, where there's huge food shortages. And this is what really launched the Green Revolution. So you cannot talk about, you know, ammonium nitrate as being a devil or an angel. It's a substance. It doesn't make any decisions. People make decisions about how to use it. People make decisions about how it should be stored, how much care should be taken. In any case, Fritz Haber was awarded the Nobel Prize for the discovery. It was an extremely controversial Nobel Prize. Not because people didn't understand the importance of ammonia. I mean, everyone understood that. No one criticized the value of the science. What they criticized was what else Haber had done. Because during the First World War, working for the German military, he developed poison gas. He was the leading scientist to do this. Now, of course, being part of the military, this could be, you know, passed off in the sense that, you know, we're in a war, you do whatever you need to do in order to win the war. And he was head of the German Chemical Corps, as it was called, and he developed chlorine gas, which was first used in Belgium in warfare, and it was absolutely horrific. When you inhale chlorine gas, it immediately changes to hydrochloric acid in your lungs, and that immediately destroys the lungs. And it's not a pleasant death. You basically suffocate. There's an interesting personal story here too to Haber. His wife was also a scientist. In fact, she was a PhD chemist. But she did not agree with the development of the poison gases. And the day after he launched the gas attack against the Allies, his wife committed suicide. She shot herself. Now, of course, there's been, you know, talk about that, issues about exactly why she did it. You know, was it because of her husband releasing the poison gas? It probably was. Because she was certainly a peace activist and was not at all in favor of developing poison gases. So Fritz Haber goes down in history, with this checkered past, that on the one hand, the development of ammonia fed people, and on the other hand, he developed the poison gases to kill people. Today, the way that you're likely to come into contact with chlorine, of course, is because it's used to disinfect water, it's used to disinfect swimming pools, and there, it's not any kind of toxic level. You just need a few parts per million to disinfect water. But where it still can cause trouble is in the home. Because if you mix any kind of sodium hypochlorite solution, that is like Javex, with an acid, and that acid can be any kind of acid. It can be toilet bowl cleaner, it can be rust remover, navel jelly, it can be vinegar. Any kind of acid will release chlorine. And there certainly have been home accidents with this. And the way that this usually happens is that people will use bleach to try to clean something, clean the sink, clean the toilet bowl, and they find that it isn't becoming clean. And they think, okay, well, now let me use some acid. And they'll pour the acid in there, and they get a reaction, and then they wake up dead. So, you have to be very careful about mixing bleach with any kind of acid. All right, but now we come to the current issue, which is the East Palestine story in Ohio. And this is just about a month ago. It conjures up images that were very familiar to us about 20 years ago in Mississauga in Ontario, when they actually evacuated 200,000 people in Mississauga because a train had derailed. And there the problem was that one of the cars of the train carried chlorine. And the concern was that the chlorine would escape. And that would have been just a nightmare. So they did manage to evacuate 200,000 people. And interesting enough, after that happened in Mississauga, the Canadian government instituted laws about the trains having to have a monitoring system on the wheels to alert in case the wheels got too hot. Because that's what happened in Mississauga, is one of the wheels got too hot, it expanded, and that's what caused the derailment. So in Canada, we have all kinds of safety features about trains carrying hazardous material. The US is a different world, especially under Trump, when all kinds of regulations were rolled back. And there was a law before that made railroad companies put on these monitoring systems. But during the Trump era, they rolled it back. And the law then became that only if you had more than 5 cars carrying dangerous materials on a train did you have to have those safety measures. That's the reason that that train only had 5 cars of vinyl chloride, because then it was essentially beyond the law. So, Trump needs to be blamed for that too, with the rest of everything else for which he needs to be blamed. Anyway, the whole issue here was the cars that were carrying the vinyl chloride. So let me just tell you a little bit about what this is. Vinyl chloride under normal conditions is a gas. But if you take a gas and you compress it, it becomes a liquid. And that's the way these things are transported, because of course it requires much less volume to transport a liquid than a gas. So you have these cars, which really are very well designed. They're often triple walled. And so it was carrying vinyl chloride, liquid vinyl chloride. Now, why is vinyl chloride being transported? Because it is an extremely useful chemical, and it is widely produced because it is the raw material to make something we call polyvinyl chloride, or PVC. Vinyl chloride is a small molecule, but when you link many of them together in a chain, you get polyvinyl chloride. Polyvinyl chloride is a hugely important commercial item. This is, for example, what our water pipes are made of. Many, many items. I mean, vinyl roofs of cars, if you remember, vinyl records, and shower curtains are made of vinyl. Now here there's another issue, which is an interesting issue, and this is the reason why we used to hear about vinyl chloride even before this accident. Because when you make polyvinyl chloride, it actually is a hard plastic, which is what you want when you have water pipes. But when you have a shower curtain, you want it to be soft. And the way that it is made soft is by adding what is called a plasticizer. It's an internal lubricant. It gets in between the chains of the long molecules, softens the stuff. There's an issue with this, because the plasticizers that are used, the so-called phthalates, polyvinyl chloride, have been blamed for having hormonal properties and contaminating the environment. So that's why manufacturers of shower curtains, for example, today will make a big deal out of the fact that they're not made of PVC, but they're made of a different plastic, usually polyethylene vinyl acetate. But there also has been a lot of commotion about children's toys, which are made of polyvinyl chloride and have to be softened. And they are softened by using these internal lubricants, the phthalates. And there has been big commotion about getting rid of phthalates, and a lot of screaming and shouting about this. And it is possible to use other softening agents, other plasticizers, and many companies now are resorting to that. So if you take a look at this little ducky here, you'll see that it is made with non-phthalate material. So anyway, that's the stuff, the vinyl chloride that was being transported in that train. And the pictures that you see, these kind of pictures, there was originally a fire that broke out just after the train went off the track, but that fire they put out. But the problem here was that everything was getting so hot that the fear was that the vinyl acetate, the liquid in the tanker car, would turn into a gas, expand, and explode. And that would have sent shrapnel from this train miles away. So that's when they made the decision. And of course, there's a lot of debate about this, whether it was the right decision or not. But I mean, supposedly there were experts involved. He said that what we have to do is release the vinyl chloride from the train and burn it outside, so it doesn't expand inside of the car. So that's the pictures that we saw, you know, that looks so frightening, is when it was being burned on purpose to get rid of it. So the story is that vinyl chloride is a nasty substance. There's no question about that. And we've known this since the 1940s, when a rare form of liver cancer was noted in workers who were producing vinyl chloride. But you have to understand that here we are talking about an occupational hazard. These were people who were working with this stuff all the time, every day, for years. I'm not talking about a single exposure. So when you hear the story that vinyl halides, particularly vinyl chloride, is a carcinogen, that is a cancer-causing agent, that is based on occupational exposure, not on one single episode like this. That's not how cancer works. It's something that you have to be exposed to over a period of time. Now, besides being a carcinogen, though, I mean, inhaling vinyl chloride is not a pleasant thing. It's a very choking kind of a gas, and people there did, of course, experience that. But also, it dissipates very quickly in the air, as you can imagine. But when you release a gas into the air, it doesn't stick around. It expands and essentially disappears. So the real problem here wasn't the vinyl chloride. The problem was that when you burn vinyl chloride, which is what they wanted to do to get rid of it and to prevent an explosion, there's a chemical reaction. And the vinyl chloride converts into HCl, hydrogen chloride, which dissolves in the moisture in your lungs to form hydrochloric acid, not a good thing. And also, it produces phosgene. Phosgene is a gas, again, that was used in the First World War as a poison gas. But the amount that was produced here was really inconsequential, very small. And those two dissipate quite quickly. Now, a residual issue, this is one that nobody knows at this point what it means. When you burn vinyl chloride, you also produce chemicals called dioxins, which are long-lasting and can get into the water, can get into the soil. And these are carcinogenic. So these will have to be monitored. But they are monitoring it. I mean, they really have put in a huge effort in testing. They're testing the soil, they're testing the water, they're testing the air. And they're testing not only for vinyl chloride, because there were a number of other chemicals that this train was carrying as well. But they were not regulated as hazardous chemicals. Only the 5 cars of vinyl chloride were hazardous chemicals. That doesn't mean that these are pleasant things, but they don't pose an immediate danger. But they did leak out and into nearby waters, and as you know, there's a huge cleanup underway. It's going to take some time. Now, I don't want to minimize this story. I mean, obviously it is a terrible thing. However, I think it has also been exaggerated in terms of its risks. And there's a need to separate fact from fiction here, because there's a lot of fiction already that has evolved. For example, headlines like this, that this is America's Chernobyl. This is idiotic. There's not one person who has died because of this accident, not one. How many died in Chernobyl? About 30,000. I mean, to suggest that this has anything like that is absolute nonsense. That was release of radioactive material, not some gas which may have some degree of toxicity for, the immediate area. So that is just nonsensical. Now here's another bit of nonsense. The train that derailed in Ohio was carrying over 300,000 gallons of a chemical that was banned in 1974. Now, that suggests that this was some sort of illegal task, that they were carrying this chemical that was banned. Well, no. Even though this scooted around, the internet and Facebook, trying to understand why a train was carrying over 300,000 gallons of a chemical that was banned in 1974. No, it wasn't banned in 1974. One specific use of it was banned, because at one time, a few companies used vinyl chloride as the propellant in some aerosol sprays, things like hairsprays. That was a stupid thing to do in the first place, because it was already known at that time that this is not an inert material, that it's not something that you really want to be inhaling. But anyway, it was used, and it was banned in 1974. That was the law, that was instituted. It was banned in aerosol cans. But that was really a trivial use of vinyl chloride. I mean, 99.9% of vinyl chloride goes to produce polyvinyl chloride, the plastic that we've talked about. So once again, to say that they were transporting a chemical that was illegal is absolute nonsense. But this is what happens, with the spread of misinformation. But I tell you what is even worse, what is absolutely truly sickening, is companies that are trying to capitalize on this tragedy. Like this company, it's called the Wellness Company, which is a misnomer if there ever was one. It's one of these telehealth companies. Now, there are many telehealth companies that are very reputable, where you actually, talk online to real doctors and you get real advice. But some of them are just absolute quack operations, just to sell you stuff. Wellness Company is one of these. So what are they now trying to do? They're trying to play the good citizen, that they're going to give free health care to the, quote, victims of East Palestine. And you know what happens? What is this good care? If you call them up and you say that you want some information, that you want their help, the telehealth help, what it comes down to is that they will tell you that you need to take various supplements to counter the toxins that were produced. With zero evidence. Zero evidence. They sell things like this, which supposedly counteracts the spike protein, which is the active ingredient in our vaccines. Because their contention is that vaccines are dangerous, and you want to counter the spike protein, which is injected into your body. This is insanity. I mean, luckily, of course, the thing is totally useless. It doesn't do anything. But that's the claim. And they got a bunch of plant extracts, like green tea extract, etc. And now, of course, they're claiming that this is going to be the way that the toxic substances that have been inhaled because of train accident are going to be neutralized. This is sick. These people capitalizing on this accident. Now, obviously, there are real issues as a consequence of that derailment, because chemicals did spill, some of them soaked into groundwater for sure. So there's an issue with the drinking water. But it is being tested, and the tap water has shown absolutely no contamination. And the city officials there made a big splash last week by drinking the tap water, showing that it isn't safe. Which it is, because we can test the water, we know what's in there. But they did say that people who have wells should not be drinking the well water until it has been tested, because they don't know what has seeped into the ground. So we'll see. Okay, well, this business of drinking water and contaminants, well, this brings us to another type of accident, which is a bit closer to home. You may have seen last week the story about the so-called forever chemicals found in a number of municipalities in Quebec. And this merits a bit of discussion. The chemicals being talked about are the PFAS, the perfluoroalkyl and polyfluoroalkyl substances. These are very interesting substances, chemically speaking, because they are resistant both to oil and to water. So if you coat paper with these, for example, it makes it impermeable to oil and to water. So you can imagine why that is of importance in the packaging industry. You can understand why it would be useful in apparel, like in raincoats. So there are all kinds of consumer products that use these perfluoroalkyl substances, which is a large family of compounds. I mean, we can look around and, things like pizza boxes, the bags in which you get microwave popcorn, The reason that carpets can resist stains is because they are coated with some of these materials, and our raincoats, etc. So they are undoubtedly useful. This, of course, is why companies use them. You know, and this is also an important thing to point out, is that no company says to themselves, let me put this useless material into my product so that we can scare the population, right? I mean, if a company uses something, it is because they see the benefit for the product. Now, truth is, of course, just because they see a benefit to the product doesn't mean that there's no issue with the product. But PFASs are extremely useful. And there are many, many of them. It's a huge family of substances. It's not only one substance. What they all have in common is that they all have fluorine atoms in the molecule. The carbon-fluorine bond is a very, very strong bond, which is good and bad, because that is the reason why these substances resist oil and water, but it's also the reason that they don't break down in the environment. That's why we call them forever chemicals, because they're persistent. And they're persistent, therefore, they eventually do end up in our water, for example. So this is the study that caused the commotion last week here in Quebec, where University of Montreal researchers, and this is a very good group of analytical chemists, so they did very good work. And they sampled water across Quebec, many, many areas, and found that they could detect some of these perfluoroalkyl substances, depending on where, anywhere from 0 to 100 parts per trillion. Now let me tell you what a part per trillion is. And the best way to do this is by means of an analogy. Imagine an Olympic-sized swimming pool. Okay, got that in your mind? It's 50 meters long, usually about 25 meters wide, 10 feet or so deep. Picture 20 of those. Now, picture putting one drop of something into those 20 pools. I mean, pooled together, I mean. That's what we're talking about in terms of parts per trillion. It's an incredibly small concentration. If you want another analogy, picture the width of a credit card. Compare it to the distance between the Earth and the Moon. That is 1 part per trillion. All right. So what does it mean that a few parts per trillion of these chemicals were found in the water? The first thing that it means is that analytical chemists today have unbelievable technology, and these usually are mass spectrometers linked to liquid chromatographs. The liquid chromatography separates compounds, the mass spectrometer identifies them. It is unbelievable that we can do this, that we can find substances down to the parts per trillion level. It basically means that if you look for it, you will find it. Okay? There are thousands and thousands of compounds in our environment that are present at the part per trillion level. But you don't know unless you look for it. If you look for the PFAS, you find them because we can find it down to parts per trillion. So there it's in the water. Now, just because it is present at such a low level, I think this is also an important point, that does not necessarily mean that it is harmless. Because there are substances that are harmful at that level. For example, things like botulin, the toxin produced by the botulinum clostridium organism, extremely toxic. You know, a couple of milligrams could kill everyone in the city. So there are some substances that are highly toxic. All right, so we find a few parts per trillion in our drinking water. Not that big an issue. Where it becomes more interesting is the finding in the blood, because it is there. I can tell you that we could draw a blood sample from any one of us in here and test it, and we would find some of these. And you would find them at the part per billion level. Now, it is somewhat comforting that over the last few years, the amounts have decreased very significantly around North America. And that's because the most problematic of these perfluoroalkyl substances have not been produced now for about 15 years, because we've known for some time now that there are issues here, that these are compounds that stay around in the environment. So the industry has switched to other PFASs, which are less intrusive to the environment. Less, not zero. So the most treacherous ones certainly have decreased. But the important question here is, what does all of this mean? Because just finding something, whether it be in our water or whether it be in the blood, does not mean that we need to worry about it. That has to be studied. It is not such an easy thing to study substances to which we're exposed in such small doses. How do we go about this? Well, basically there are three methods that we use in order to find out if something is potentially dangerous. The most basic are the so-called in vitro studies, which one can do relatively easily. In vitro, literally, it comes from the Latin, it literally means in glass, which means in the laboratory, where you're using glassware, you're using test tubes, you're using Petri dishes. You can do a number of toxicological studies on cells, because you can grow cells in the laboratory, you can culture the cells, you can expose them to a substance, and obviously you can decide what concentration you want to expose to, and you can see whether or not something happens to the cells. Do they die? Do they become cancerous? Do they develop abnormalities? So you can do these kind of studies. This is called in vitro. However, we are not large test tubes. We are not large Petri dishes. So just because something happens in the lab doesn't mean that it's going to do anything in the body. That needs much more exploration. So really, what an in vitro test is a springboard for further tests. If you find something that is of concern when you look at cells in the lab, it means let's look further. Well, where do you look further? The next step is to do what we call in vivo experiments, where you expose some animal. Now, usually these are mice or rats, because those are the easiest to work with in the laboratory, to the substance, and you try to do this in different doses. Now, of course, this is already much more complicated than an in vivo study. You don't have to feed your test tubes or your Petri dishes. You don't have to clean up after them, right? So dealing with animals already makes things much more complicated. And of course, we are not large rats or large mice either. And there are certainly substances that are dangerous in animals and not in humans, although there's probably some vice versa at all, because after all, no matter what animal you're using, it's not a perfect model for a human. So there's still a lot of guesswork that is involved here. Then, of course, you also have the issue that these animals don't live as long as we live. So what you try to do is estimate what might happen in someone who lives for 70 years, modeled on a rat that lives 2 years. So how do you do that? You hope that feeding a large dose to a rat that lives for 2 years mimics what may happen to a human fed small doses over decades. It's a guess, is what it is. What we really need, of course, to get information are human studies. But you cannot do, in terms of toxicity, you cannot do intervention studies with humans. You can't do an experiment where you set up 2 groups and you feed these PFASs to one and not to the other to see what happens. Right? So you can't do that. So what are we left with? We are left with what we call observational studies, which means that you can observe a population, you can follow them, you can measure whether or not they have substances in their blood, and see if there's any kind of relation to disease. And this is where we get some warnings about these perfluoroalkyl substances. Because when you look at populations at large, and you take blood samples, and you measure the amount of these PFASs that are present in their bloodstream, you find that there are some associations. And you find that the higher the level, the higher cholesterol levels. The higher the level of these PFASs, the more poor the response to vaccines. So you do find these things, which of course does raise somewhat of an alarm. But again, here, we have to introduce the idea that an association can never prove a cause and effect relationship, because there might be other confounding factors here. It may well be that people who have high levels of PFAS in their blood, where does that come from? Maybe it comes from the fact that they're eating a lot of processed foods. They're eating a lot of pizza that was packaged in cardboard treated with PFAS. That may be the issue, may be the food that they're eating. So you can never, with an association, prove that something is causative, but at least you want to be aware of this. So with the PFASs, based on the in vivo studies, the in vitro studies, the human clinical studies, we can say that there is smoke. Now, whether that smoke is coming from a potentially blazing inferno or from a match, that is very hard to say. But certainly, we know that these things in the environment are not doing any good. So if we can curb their existence, the better. Of course, then you also have to give up some of the comforts that they give us. So anyway, regulatory agencies are looking at this, and they want to limit the amount that is out there. And one way to do that is by limiting the amount that can show up in water. So in Canada and the US, there are discussions about this. Canada wants to be extremely conservative and wants to introduce the limit of 30 parts per trillion in drinking water as the limit. The US, they'll go up to about 70. Now, it's fine to say this, but how can this be put into practice? Because you need the technology to take these substances out of the water. And right now, on a municipal scale, that technology does not exist. These things get into our water in all kinds of ways. Obviously, wherever they are produced, wherever they are manufactured, they can seep into groundwater. When we throw out things that contain PFAS, they go into landfills from where they can go out. So eventually they can come back to haunt us. So the question is what to do. On an individual level, if you are concerned about these chemicals, there is something that can be done, because there's a filter that has been developed. And this is it. It's called PureFast. And It isn't made by Brita, but it fits into a Brita jug. And this will remove the perfluoroalkyl substances. It is also possible to remove these by another filtering system, but that is very expensive. That's reverse osmosis. Reverse osmosis takes out almost everything from water. But a setup like that costs about $800. You have to keep changing the filter. It also wastes a lot of water. But for anyone who's really concerned, it can be done. I'm not too concerned about the parts per trillion of PFAS in the water, because in comparison to everything else that it costs us in life, all of the bacteria, all of the viruses, the phthalates, the bisphenol A, the benzene evaporating from, every time we fill up our car, etc. I think it makes a very small contribution. So I would not put really very much emphasis on trying to get rid of it from the water. The way that we have to approach these problems of substances that are so environmentally persistent is to not let them get into the environment in the first place. So this is where we have to ask the question, do we really need microwave popcorn? Do we really need that pizza box to be resistant to all, oil and water? So what if it gets a little soggy, right? Do we really need to Scotch guard our furniture and our carpet? Do we need to make sure that when your French fries are put into that little carton, that none of the grease soaks through? So what if it does? You should anyway worry more about what's in the French fries than the carton that they go into. So I think this really is what we have to look at, is cutting down on what is being put out there in the first place. Now, in terms of this packaging, you may have seen recently this PFAS found in all kinds of food products. Well, they are, I gave you examples, but it's also interesting that as illustration to this article, they use potato chips. Now, I don't think the potato chip bag contains any of the perfluoroalkyl substances. The potato chip bags are made of polypropylene, polyethylene, and aluminum, and there really is no issue with that. But I can tell you that there's almost nothing today about which someone will not find an issue. What's the most recent one about potato chips? The alarm. Shocking study reveals average bag of chips contains 43% air. Right? You open that bag of chips and it's only half full. Good, you shouldn't be eating a bag full of potato chips anyway. All right, then you see studies like this about the amount of air that is contained in those potato chip bags, kind of insinuating that you're being scammed, and that you should be going for the bag that contains the least amount of air, because then you're getting the most chips. Well, that's ridiculous on many levels. First of all, potato chips are not sold by volume. They're sold by weight. So all you have to do is look on the label and see the weight. And you see that the weight of the chips doesn't differ here. It's roughly the same amount. The other thing here is this business about it being filled with air. It actually isn't filled with air. It is filled with nitrogen. Now, nitrogen is present in air, of course, or the air that we breathe is 80% nitrogen and 20% oxygen. There is a reason why that potato chip bag looks the way it looks, right? It looks bloated, right? And it does contain only by volume half chips. Why? because oxygen is the poison as far as potato chips are concerned. Oxygen reacts with fat and makes them rancid. This is what happens to butter. If you leave it out too long, it becomes rancid. So how do you protect the potato chip from reacting with oxygen? By not having any oxygen in the bag. So that's why you use only nitrogen. It makes for a better chip. That's all there is to it. This is not a scam. I can tell you that the technology needed so that that potato chip bag is filled with nitrogen instead of air is an expensive technology. It will be much easier to just fill it with air. But the idea is to deliver a better product, at least in terms of rancidity. So this is really not something to be concerned about. You don't need to worry about the nitrogen in the potato chips. If you want to worry about something, worry about the potato chips themselves. Because never mind the fact that they obviously contain fat, that's what they're fried in. But the very frying process produces a whole slew of compounds called advanced glycation end products, one of which you probably heard of is called acrylamide. That's the one at the bottom corner. And when you take glucose, which is present, of course, in potatoes, and asparagine, which is amino acid also present, and you heat it up, you get acrylamide. Acrylamide is a known carcinogen. So that would be a much more reasonable concern about eating potato chips than the nitrogen in the bag. So of course you don't want to overdo eating potato chips. But who can stop at one, right? As the ads tell us. Well, if you want a long life, yeah, it's better to stop at 1 or 2 or 3 and not have whole bags of this stuff. Because one thing that we know, and this is pretty ironclad when it comes to nutritional science, we know that cutting calories increases longevity. We know this. Starting back in the 1930s, Dr. Clive McKay noticed that when he put mice on a low-calorie diet, they lived about 25% longer. This was corroborated by Dr. Roy Walford, who today is looked back upon as the pioneer of calorie-controlled diets. And he did, again, experiments with mice, showing that if they were allowed to eat as much as they want, they lived a lot shorter time than the ones that were put on a regular low-calorie diet, calorie-restricted diet. This was then shown with other animals as well, ones that are much closer to us, chimps. And they are the same age. The only difference between these is that one had their calorie intake controlled, the other one was allowed to eat as much as he wanted. That's the one that got old and ragged, and the other one was youthful and strong. We have some interesting evidence from population studies in humans as well. If we look at Okinawa, which is an island in Japan, they have an astounding number of centenarians, and the average life expectancy is very long. When you look at their diet, one feature that crops up right away is that it is a very low-calorie diet. They don't eat foods fried in fat. It's a lot of fruits, a lot of vegetables, seafood. They eat soy, a lot of seaweed. Now, of course, it's difficult to say here whether the benefits are due to the diet being low-calorie or the composition of the diet. Or is it genetics? It's likely a combination of all of those. But now we even have scientific corroborative evidence We have studies that have shown that DNA survives better, it doesn't degrade as easily in people who are on a habitual low-calorie diet. And you can quite easily decrease your total calorie intake by about 20–25% without it having any nutritional deficiency. You just have to make sure that you're getting all your vitamins and minerals, which is certainly possible to do. In North America, we overconsume calories. Doesn't mean we need to be extreme. Moderation. But like I said, there's not too many things, that we know for sure in nutritional science. But this is something that has been demonstrated over and over again, that reducing calorie intake extends life. One way to do that, of course, is to reduce your sugar intake. So I want to finish off here with just this last little story, because this was in the news last week. And it was about a sweetener that you may not even have heard about before, called erythritol. But it's there. You can find it on the shelves in the supermarket. You can buy it online. But where you are most likely to find it is in these keto foods, like keto ice cream. These are these low-carb products which are supposed to be healthy, and you can see it there, the erythritol in the third line. It is also, interestingly enough, there in combination with some of the so-called artificial sweeteners, like stevia. Now, the reason that it's there is to act as a bulking agent, because the active ingredient of stevia is so sweet that you need very little of it. But it's very difficult to handle. So you want to be handling spoonfuls of the stuff. So it means that you need a little bit of that and some other inert material. And this is where we see the erythritol. As you can see, there about 3 grams. So what's the issue here? Erythritol is in a class of molecules that we call sugar alcohols. Chemically, they are very similar to sugars, and the difference is that while they have sweetness, usually about 70% that of sugar, they're not digested. They're not absorbed by the body, they go straight through. So if you see a chocolate like this with no added sugar, what we're talking about is some replacement that gives it sweetness, right? But it isn't absorbed, it's not contributing calories. And you can see maltitol and lactitol are 2 of these sugar alcohols. Now, the main side effect of maltitol-lactitol is that in some people, it causes loosening of the bowels. It can act as a laxative. Now, it turns out that erythritol has minimal that effect. Mannitol, lactitol, xylitol, those can cause what they sometimes in the trade called anal leakage, not something you want to ever deal with. But apparently erythritol, that's not an issue. But what became an issue, and we first heard about it last week, was this. Sugar substitute erythritol may increase risk for blood clotting and stroke. Not something you want to see. We saw this in a study that was carried out, and the study was done at the Cleveland Clinic, which is one of the most reputable medical establishments. So this is, this is not quackery at all. So what did these researchers do? They investigated samples of blood that had been taken from people who were involved in an ongoing study where they were monitoring their cardiovascular risks. These were people who had been enrolled in the study because they had cardiovascular risk factors, such as obesity, high blood pressure, high cholesterol. So this was already a population that was somewhat at risk. So what did they find? They studied their blood because they were looking to see, is there anything in the blood that can predict a future cardiac event? This is obviously of interest to researchers and to the population at large. And this is what they discovered. It was really an accidental finding. This is not what they were looking for. They just happened to find that people who had high levels of erythritol in their blood were more prone to having a heart attack or a stroke. Now, in order to have those high levels of erythritol in your blood, it can only come if you are consuming this in the diet. Either if you're baking with it, or you're eating foods in which it is contained. Because small amounts of erythritol do occur naturally in the body. They also occur naturally in plants. But you cannot get those high levels naturally. It has to be from consuming these foods. So the question was, what's going on? Now, how can this simple sugar alcohol have an effect on heart disease or stroke? So the first question you think about is, could it have an effect on blood clotting? Because if you get a blood clot, you can get a heart attack if it happens in a coronary artery, or a stroke if it happens in the brain. So blood clots are not good, right? This is something that you try to avoid. So the first question that the researchers asked, is it possible that erythritol has an effect on blood clotting? So what do? The first thing, you go into the lab and you see whether or not you put blood into a petri dish, you put some erythritol, does it affect the clotting? And they found that indeed it did. Next, you go to animals. Well, they found that when they looked at mice, the same effect as in humans. When they caused an injury to the mouse that would require blood clotting, they found that if it had a higher level of erythritol in the blood clots formed much more easily. And then they even carried out a human trial where they had 8 volunteers who drank 30 grams of erythritol dissolved in water, because that's the amount that someone who is, on a keto diet would take in. And again, they found that blood levels of this increased with that intake, as you would expect, and it also had an effect on blood clotting. So that's the story that we heard last week, and of course, the manufacturers of erythritol fight back, and they say, but look, this is approved by authorities around the world because it has been shown to be non-toxic. Indeed, yes, that's true. You cannot put an artificial sweetener on the market without showing that it is non-toxic. But what is involved in showing that it's non-toxic? All you have to do is to show that it's not acutely toxic in test animals. You give it to them in varying doses and they're not dropping like flies. So there's no imminent toxicity. There's no requirement to see whether or not people who have pre-existing risk factors for heart disease who take this substance over a long period of time. There's no requirement to study that, which would also be, very difficult to do. So this, the use of erythritol is just another example of how quick solutions are never the way to go. It's if you want to lose weight, you want to control your calorie intake. Turns out that using some sort of substitute is never works in the long run. What works in the long run, as you well know, is a balanced diet. And then you don't have to worry about the erythritol. You don't have to worry about the FASs either, because those mostly are in highly processed foods. So the bottom line here is, when you go to the grocery store and you're walking down the middle aisles, leave your basket empty, right? Go around the periphery, and there you can fill up on all of the produce. And you don't have to worry about erythritol or any of the other things that I mentioned. So that's what has been in the news in the last couple of weeks, and hopefully now you have a bit of better understanding of what's happening. So if there are any questions, we can certainly try to, yeah.
If you buy water, does it have all those drops?
Okay, the questions about bottled water. It depends on which bottled water. Just like with everything else, you know, there's a huge variety. A lot of the bottled waters are just tap water, which then are passed through a filter, but those filters will not take out the substances that I talked about. There are many environmental issues with bottled water, starting with the fact that where does that bottle go? Unfortunately, only about 25% of those bottles get recycled. The rest go into the garbage. Very often they end up in the ocean, where they get broken down, and you get microplastics, which, you know, then contaminate the water. So now, you know, I'm not a fan of bottled water. I think the only time that should be consumed is when there's some sort of advisory, you know, that there's some issue with tap water. But I don't think it should be consumed on a regular basis.
They have an advisory about lead in the water.
The what?
Lead.
Lead? Lead in water can be an issue. Now, this is, in that respect, you won't find lead in bottled water. The lead issue is from the pipes. Okay, and in some of the older areas, the pipe by which the main water line is connected to the house is made of lead. And now you don't want lead in your water, however, that really has an impact when you're talking about infants or during pregnancy. None of you here fall into that category, so that you don't have to make yourself crazy.
In my case, I can drink the tap water.
Yes. You're not pregnant, I assume.
No,
Yeah.
no, yeah, that's not.
Yeah.
What happens if the water looks like filmy?
It's just like that, I can't tell. I mean, you know, it has to be looked at carefully. I mean, that can be many different things. You thought tap water, you're talking about?
Yeah.
What do you mean filmy?
Hazel. No, but it's not clear. Hazel.
I mean, the not clear can be many things. It can be just tiny air bubbles, you know. See if you leave it, take a glass of water and leave it out, does it become clear?
Yeah, clear.
Well, then it's air bubbles. If it becomes clearer by just standing.
Trained in lactic acid, what is the chemical exposure there?
Sorry, in?
Lactic acid, remember there was a big train,
Red modernity.
lactic acid, there was a train exploding in the village, and the whole village was, town was destroyed,
Yeah, it was oil.
so what are the repercussions of that?
They cleaned it up. I mean, the repercussions of that mostly on the life in the water, fish. They're very sensitive to oil.
It's rebuilt and it's a whole new.
Yeah. I mean, it's been cleaned up. Look, we live in a complicated world. You know, when you produce substances by the millions of tons, you know, all around the world, you're producing metals, you're producing plastics, you're producing cosmetics, you're producing drugs, you know. Stuff will happen. I mean, it's, you know, In fact, the more you know about, what is being manufactured and how and what is being transported all around that, what is really amazing is how rarely these things happen, and how smoothly things work most of the time. And, with trains, actually train accidents are not that rare. Trains go off rails quite often. The reason that we hear about this now, of course, is because of the particular cargo that was being carried. But it's not unusual for trains, freight trains, to go off the rails. It happens, I think the statistics are, it's roughly 1,000 times a year. Yeah. But most of the time it's nothing, they bring a crane and they put it back on. This one wasn't like that. So, it's a complicated world. There are no simple solutions, and you want all the luxuries of life, which we have. We all love to walk around with those cell phones. Well, someone makes them, and when you make them, you use huge amounts of all kinds of materials, heavy metals and plastics and insulators and, glass and everything. And all of that has to be made and transported. And so, yeah, stuff will happen. Live with it. Okay? All right, see you next month.